7.31, the elastic collision of your homework. This is something that we have not done in class. This is something that you would only get from looking it up or looking at this video. So if you get this problem right, you either saw the video or you simply looked up the answer. It makes me so proud. Alright, 7.31. It says a ball of mass 0.305 kilograms that's moving at a speed of 5.4 meters per second. So, say this one. 5.4 meters per second. Moving to the right, it's got a mass of 0.305 kilograms. Hits and collides with another ball initially at rest. So this one's not moving. And let's see. We don't know the mass. Immediately after the collision, the incoming ball bounces backwards with a speed of 3.5. And presumably ball 2 goes flying off that way. Well, this is an elastic collision where kinetic energy is conserved. Okay, it's very, very important that it's conserved. What does that mean? That means that the kinetic energy before this collision is equal to the kinetic energy after the collision. And kinetic energy does not care about direction, so however much we have is however much we have later on. Now, the first part of this problem says calculate the velocity of the target ball after the collision. Well, this is a collision problem, and so I can make my equal sign, and before this collision I have the mass of 1 and the velocity of 1 plus the mass of 2 and the velocity of 2 equals the mass of 1, the velocity of 1 prime, plus the mass of 2 times the velocity of 2 prime. What the heck did I just do is what you're saying. This is momentum. Okay, this is conservation of momentum. All we're saying is that the momentum of each object in the beginning, we're caring about direction, so I'm just going to add them together, velocities could be negative, is equal to the momentum of these objects at the end. Alright, so the velocities probably changed since they hit. All we're saying is the momentum of that guy and the momentum of that guy added together is equal to the momentum of this one and the momentum of this one afterwards. Okay, let's see if this helps us out at all. So M1 we know, 0.305, and we know the velocity, it's 5.4. M2 we don't know, but we do know is that V2, the velocity of this in the beginning before the collision, is nothing. So that's 0, it's gone. I can just put my equal sign already. Okay. After the collision, the mass 1 still exists. It's still 0.305. 0.305. The velocity after the collision is 3.5. Be careful here, because the velocity is negative. It's negative because it's going the other way. You guys know this. Use it. Okay. Plus, M2, we still don't know what M2 is. And we don't know what the velocity of 2 is after either. So we're kind of screwed at the moment, aren't we? M2, V2, we have no idea what that is. And if that's the only tool that we have, then we're stuck. Okay? Here's what you do. You've got a book. You got an ebook. It's up and to the right. You click on ebook. You can bring up the momentum chapter. You can go to elastic collisions. It gives you a handy dandy formula that I can derive for you, or I can just give it to you. Which would you prefer? You say? Yeah, just give it to me. So, the velocity of object 1 plus the velocity of object 1 after the collision is equal to the velocity of object 2 plus the velocity of object 2 after the collision. This equation is a magic equation, which means it comes from doing a bunch of math, okay? This just popped out of nowhere. So, be very careful. This equation is only good whenever you're doing elastic collisions. Elastic only. The reason why is because it uses conservation of energy to get to this equation. Listen very carefully. If you use this with an inelastic collision, you're going to get it wrong. This is only a trick specific to elastic collisions. Don't mess that up. Okay? So, this is going to help us out. V1, 5.4 plus V1 prime after the collision, negative 3.5 equals V2, nothing, plus V2 prime, plugging stuff in. what do we get? 5.4 minus 3.5 gives me 1.9. V2 prime equals 1.9 meters per second. We are done. Magic. You ever wonder why the wizard is our mascot? That's why. That's part A. Part B is a little bit more, well, asks you for a little bit more. Calculate the mass of the target ball. So we're looking for, this is part A. Part B is looking for the mass 2. What is it? Okay. Well, we got it set up already. It's, this is all right here. We can find mass 2 if we knew V2 prime. We know that now. So I'm just going to be pretty complete about it. 0.305 times 5.4 is equal to 0.305 negative 3.5 plus, off the page, m2 times 1.9. That gives me an equation with one missing thing. And so, again, I'm going to be very, very thorough with this as far as the math goes. Usually I'm not in class. I skip around a bit. I want you guys to be on your toes in class. If I'm going to move this to the other side of the equal sign, this is a negative. I need to have a positive to counter it. So plus 0.305, 3.5 equals m2 1.9. Okay? So let me find a sum on the left side. 0.305 times 5.4 plus 0.305. I could have 3 and 5, 8, 4 and 5, 9. Okay, whatever. 2.7145 divided by 1.9 gives me a mass of 1.4287 kilograms, and we're done. That's it. Yep. Elastic, magical equation. Write it down, keep it. You're going to need it. We'll talk about elastic a lot more. End of the semester, though, so see you guys whenever I see it. Rube Goldberg's going out right now. And we're done.